Welcome to Indices Part 6. Indices Part 6, which is actually a continuation of Indices Part 5, meaning I have done a video on Indices Part 1, 2, 3, 4, 5 before this Part 6. 6 is simply a continuation of Part 5. So, under Indices Part 6, we have two examples. Simplify this, and then the second one is given that this is equal to this. Find the value of x. Let's start with the first one. You want to simplify 0.2 raised to power 3 times 8 all over 0.4 raised to power 2. 0.2 is the same thing as 2 over 10. Then there is already power 3. Then times 8 all over 0.4 is the same thing as 4 over 10. Let's continue at that point. Now, you can reduce this to the lowest 10 first, or you take in the power. Recall from our knowledge of indices, if you have an expression like this, x over y raised to power n is the same thing as x to power n over y to power n. So which means that this can be expressed as 2 raised to power 3 over 10 raised to power 3. You can still express it like that, or you reduce it first. So if I want to reduce it first, this is 1 and this is 5. That will give me 1 over 5 raised to power 3 times 8. Of course, this means divided by. I can still reduce this 2 here 2, 2 here 5. So divided by 2 over 5 raised to power 2. And so this will become 1 raised to power 3 is 1. 5 raised to power 3 is 5 times 5, which is 25 times 5. That will give you 125 times 8. When you change this to multiplication, what is down will go up and what is up will come down. So this becomes 5 over 2 raised to power 2. So this is giving us 1 over 125 times 8 times 5 raised to power 2 is 25. And then 2 raised to power 2 raised to power 2 is 4. And so at this point, 4 can cancel here 1, 4 can cancel here 2. 5 can cancel here 5, and 5 can cancel 12. 2 times remainder 2. Carry and add, it becomes 5. So 5 goes into 25 5 times. 5 goes into 12, 2. Remainder 2. Carry and add, it becomes 25. 5 goes into 25 5 times. So we are left with 2 times 5, which is 10, all over 25. And 5 can go here 2, 5 can go here 5. So the final answer is 2 over 5. That's the answer to question number 1. That's the answer to question number 1. Quickly, let's look at question number 2. Number 2, given that the cube root of 4 raised to power 2x is equal to 16, what is the value of x? Cube root of 4 raised to power 2x is equal to 16. There are many ways of solving that question. From our knowledge of indices, fractional index law. Fractional index law states that if you have x raised to power m over n, it is the same thing as the nth root of x raised to power n. write it again. It is the same thing. X raised to power m over n is the same thing as the nth root of x raised to power n. It can also be written as the nth root of x, the answer raised to power m. So I'm going to apply that law here, which means that this expression can be written as 4 raised to the power of 2x over 3. That's the meaning. If you compare this and this, you have this. So we call that fractional index law. That's why I advise, if you have not gone through part 1, part 2 till part 5, try and go through it, especially part 1, because I have explained the laws of indices under indices part 1. And so this is equal to 16 is the same thing as 4 raised to power 2. 16 is the same thing as 4 raised to power 2. Still, from our knowledge of indices, the base here is 4. The base here is 4. It therefore means that the power in this side must also be equal to the power in this side. Since the base in the left-hand side is equal to the base in the right-hand side, it implies that the power in the left-hand side must also be equal to the power in the right-hand side. And so at this point, we can cross multiply. If we cross multiply, we have 2x is equal to 3 times 2. And so 2x is equal to 6. Our aim is to find the value of x. Our aim is to find the value of x. So at that point, for x to stand alone, we are going to divide both sides by 2. If we divide both sides by 2, x will stay alone. So 2x divided by 2 is equal to 6 divided by 2. Therefore means that x is equal to 2 here 1, 2 here 3. X is equal to 3. That is the answer to that question. So with that, we have come to the end of indices part 5. Oh, sorry, indices part 6. Thanks for watching and bye for now.